Okay. So just now we have finished the linear regression. In the linear regression, we got 64% and 58%. Now I am going to demonstrate k nearest neighborhood. So k nearest neighborhood is basically instantaneous based regression approach. So it doesn't fit any equation based on the nearest neighbor points. It basically finds the neighbors and the user specified neighbors, and based on that it will give the average. So it will try to find the who is for the new data. It basically try to find the neighbors, and based on the neighbors it will give the prediction. But how to find the optimal k, optimal size, optimal neighbor number? So that's the reason we have discussed the concept called hyperparameter tuning. So in this particular code, what we are trying to do is basically we are specifying multiple k values, and we are asking them to find the best k value based on the cross validation. So this method, what we are trying to do, we are doing a grid search. So we are specifying, because in the k nearest neighborhood we have only one hyperparameters, that is k. So what I am trying to do, I am giving k 1, 3, 5, 7, 9 up to 21, and I am asking system to give the best k value based on the cross validation error. So then what we can do, based on that we will choose the k value and fit the model and test, train and test accuracies. That's what we are doing here. Let's run this. So what it does is basically it started doing that. So it has done all the analysis k neighbor 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, and it has given what is the best k value. K value is the best is 9 further. Now what we need to do, we need to specify this k value and fit the model. So that's what we are trying to do here. So what we are trying to do here, now we are running the final model equal to k nearest neighborhood regression. Neighbor, what is the k value we obtained? We obtained k as 9. That's what I am specifying here. Model dot fit x underscore train and y underscore train. Predictions, what I am trying to do is basically I am trying to predict. I am doing the prediction for training, and I am basically calculating the mean squared error as well as r square also. Wait, r square. Let me also paste r square also. Let me do the mean square error as well as r square value also. R square is basically what? Y underscore variable and predictions. Okay, that's what we are doing. So then we'll do the test data. So what we are trying to do now, we obtain the k as 9, and we are finally fitting the final k nearest neighborhood, in which I am giving 9 as the hyperparameter, which we obtained through the hyperparameter grid search, and trying to predicting this value. So we got this value yr square. I know I am making a lot of mistakes today. Wait, guys. And capital Y underscore train. My goodness. Some places small, some. So we are getting around 51% of accuracy. Not a great compared to regression. Now same thing we'll do it on the test data also. Test data, what we can do? We can just, we already have the model. So we are doing Y underscore here, what we can say, X underscore validation. Then we say predictions test. We are predicting on the, then, and print mean square error Y underscore validation and the predictions test. Predictions test, and if you also predictions test, and this becomes your Y underscore validation. That's what here we are doing. So here we apply the k nearest neighborhood and then the hyperparameter and go. So very poor fitted case, it's only given 25. So obviously k nearest neighborhood is not working very well, because it's the instantaneous approach. Might be your project might work well. So this is how we will run the k nearest neighborhood method. Now let's do the one more method, that is called support vector machines. Now we are doing all these individually. So what we do, support vector machine is basically a is a technique where we try to find the optimal line. Optimal, it's try to find a what is that? It's try to find a line. It try to find a what is the support vector mission? Support vector mission try to find a non-linear. It's a kernel-based technique. It try to find the margin, which will try to find the equation which give the maximum between the groups. So for that, actually, we have different kernel functions. In terms of linear regression, we are using linear, radial Bayesian function, polynomial is the function, and the distance between the support vectors and the optimal hyperoptimal line is basically the C value and gamma value, epsilon value. So there are some 4 parameters that in this support vector mission. So in this code snippet, what we are trying to do is basically we are running the support vector mission regression and also giving hyperparameters like linear, RBF, plotly, and try to find the best parameters, then use that parameters and running the model and try to find the best parameter. Like what we did the same we are doing for here also, but there in the k nearest neighborhood you have only one parameter. That's why we have done that search. But here we have like 3 types of parameters are there: kernel and gamma and C and epsilon. So we are running the grid search CV and try to find the what is the best combination of the parameter, hyperparameter, using that best combination and build the support vector mission, support vector regression. So that's what I am running here. It will take time. So it ran the given parameters. It finally ran and given the best combination. What is the best combination? It has given C10, epsilon 0.5, gamma value this, and linear function. Now what we will do, we will take this and fit the model. So model SVR regression C equal to 10, epsilon now it's actually given 0.5, and gamma is the same value. Linear I am putting. Actually, what I am trying x underscore train, y underscore train. Then here I am predicting a x underscore train, and then I am doing the prediction mean square error, and similarly I can calculate r square also. So individually we are running each method. Here if you take r square, and this is what your r square. This is what we are doing on train data. If you see r square, we got 21%. Actually, this is also not working very well. 20% of r square. So similarly, what we can do, same thing we can do it on the test data also. So test data, what we can do, model.predict. Here what we need to say, x underscore validation, and here mean square of y underscore validation and predictions test. So this is what, but mean square, we always need r square to compare. So r square is basically this one. So even SVM is also not working well on this. See 27. So that's what these techniques are doing. Individually, this is how you need to run. So the take is basically what, once you read the data, once you change that scale type properly, once you understand the relationship between the data and variable, if you want to run the linear regression, this is what you need to run the linear regression. You don't need to apply that, pipeline always. You can just take the linear regression and show your project is also fine. This is how you need to run the linear regression. If you want to run the k nearest neighborhood approach, this is what the code snippet in which you are trying to find the optimal k and fitting the model. If you want to do the same thing using the SVM support vector regression, this is what we can do. Now we already discussed, ensembling regression also, like random forest, those kind of things also. But very small data, we cannot use random forest is also one technique is there. So now I will show how to use the random forest regression on this data. So in the random forest regression is basically very simple. In the random forest also, like we have hyperparameters. What is the hyperparameters? How many trees we need to build, how many features we need to consider, how many splits we need to consider. That's why these are the parameters. Once again, what we are trying to do, we are running the random forest regression and try to find the best combination, best variable. Yeah, it's running. It basically will give the best combination, best scores, and best parameters. Use that parameters and run the random forest regression, and take the important variable. Use the linear regression. Similarly, what we did in the classification also. Always we'll use the random forest to select the variables and use those variables in the linear regression. Here also what we are trying to do. So random forest has given 62% regression. And what is the best combination? Bootstrap equal to true, max feature equal to SQRT, minimum sample split equal to 8, number of trees we need to fill is the 10. So now we got the hyperparameters and use this best combination of parameter combination and try to build, what is the random forest and random forest basically. That's what you are trying to do. So this is what your random forest, and in the random forest also will give the feature. Oh, sorry. Yeah, random forest x underscore validation. Yeah. So this is what the random forest we have run after on the train data, test data, and also in the random forest always it will give the feature importance. What is the feature importance is given? Rank, years of service, because we have only 3 variables. It has given all the variables. So we are taking all these variables because random forest is very difficult to interpret. So that's why what we are trying to do is always trying to build the linear regression only. So that's why we are once again building the same linear regression. So these are the variables. Now extra and X validation train test 70%. And we are standardizing X value, Y value and fitting the regression. So when you put the regression, this is what it is coming. I am not using GBM. So now we can use these values and try to see the your R square value for both train and test. So with shortlisted variables. Wait. Yes. 1 minute. Yeah. No problem. Okay, predictions may already we have done the test. That's why it's coming like this prediction test. Because it's other. So this is the train. This is for train data, and if you take that same test data, y underscore validation, and I think this is the pipeline basically prediction test. Okay. It's also giving around 5488. Exactly same value. How come it's possible? Prediction test. Scale validation X into the prediction. Anyway, so this is what the pipeline of the regression. So if you understand what we have done in this pipeline, we just read the data. We have tried to remove the missing value, understand the data using distribution, and try to find the removing the outliers. Then if you want to see, there is no need to mandatory that you need to run the pipeline. I just show it. But as being regression, you can take any of the technique and run individually. In case of suppose if you want to run the straight away linear regression, you can run the linear regression like this. If you want to run the k nearest neighborhood, this is what how you should run the k nearest neighborhood, in which we are doing hyperparameter tuning also. Similarly, we did the same thing for SVR support vector regression also, and here we also done the random forest regression also. So, but whenever we are using the random forest regression, always our idea, take the random forest regression, try to find the key variables and use that variables and fit the linear regression. That's what we have done. So suppose this you should take as a code template and try to find one problem where you can fit the regression and try to predict. Similarly, whatever I have given earlier, take that as a process template and try to build the classification problem. So now I will send this thing also. Now you have like a classification problem and regression problem, because you have some time. Now I am giving 1 week time. Next 1 week you guys search. If somebody want, so every section we have 6 groups. Three groups should do the classification problem, 3 groups should do the regression. Similarly, applied stats also 3 groups should do the classification problem, 3 groups should do the regression problem. So now I have given code snippets and templates for both classification and regression problem, along with thesis format also. For this also I will send. As I told you that chapter 1 is the description of the problem. Chapter 2 is basically machine learning concepts. Chapter 3 is output. Chapter 4 is conclusion. Similarly, I will send the PDF for the regression problem also. Now you guys go through these two and come up with your own data. Find some kind of data sets. Use Kaggle, use any internet, and try to build, try to take some problem. If somebody is working for classification, search data sets for classification and try to run in these lines. If you are not able to run, at least send the data. I will run and I will show it to you. And similarly, regression people also find some data where you wanted to predict the continuous variable regression problem. So you guys select the problems and get back to me by after Pongal. So what we can do after Pongal, one day we'll connect. I will connect by each group individually and I will run and we can finish the task. Is that okay? Guys, is that
Yes,
okay?
sir.
So now you guys need to come up with what? I will send this also straight away.